today we talk about test item analysis. Okay. Sometime when we see a question paper, sometimes somebody said that okay, this question is very easy, oh this question is very difficult. Now, how we say this question is easy and this question is difficult? In the what basis we can say that this question is very easy and this question is very difficult? Somebody say, oh, this is my experience. So, maybe some question is easy to some person, but maybe that same question is very difficult to the other person. So, it is subjective. So, can I measure that easiness and difficultiness in objective manner? That means, based on data, can I prove that yes, this question is easy because of this, this question is difficult because of this evidence. So, how do you calculate the easiness and difficulty index of a question? Many times, then you can say what is the relevance with this topic in this teaching and learning. Now, teacher, somebody may say that okay, this year I will design a question which is very difficult. What do you mean by that? As a teacher, can I say based on this data, I said these types of questions are very difficult. Based on this data, this type of questions are very easy. So, there is a procedure to finding out the easiness and difficulty index of a particular questions. So, here questions means test item by which I want to assess the student's competence. So, test item are the instrument by which I want to assess the student's competence, and those test items are called questions in your examination. So, for every questions I want to find out the easiness and difficulty index of that questions. How do we calculate that? So, before I taking the exam or unless I have a past exam data, I cannot say that this question is very difficult. So, suppose I design a question paper and I take a test in a class, and after taking the test, based on the evaluation result, I can say this question is difficult, this question is easy. So, analysis of that is called test item analysis. So, today I will discuss how to calculate those easiness and difficulty index quantitatively based on previous exam result. So, after the exam, after providing the marks to the students, the teacher's job is not finished. So, for every questions you have to analyze these things and find out what is the easiness and difficulty index of that particular questions. And this is context. So, some questions which is created for particular program of a particular institute, and if you collect the data based on that group of students, that easiness and difficulty index may not be valid to other group of students. But if your group size is very large enough, then I can say statistically this is valid data. So, I am saying suppose you are designing a question paper for your college or for your institute, for your department, you analyze this kind of test item analysis and calculate the easiness and difficulty index for year after year. Once you have a valid statistical numbers, then you can say this is more or less very same across the year of students. Similarly, if I put more different institute data together and then I calculate, then that also statistically validate the easiness and difficulty index for that group of students. Then how do you calculate this easiness and difficulty index? Think about just simple analogy. Suppose I have 100 students in my class, okay, and I design a question paper which consists of, let us 2 questions, 1 and 2. And question number 1, all 100 students has given correct answer. Then what is the easiness of that question? And that easiness is called facilitation value, FV. FV. Facilitation value, or how easiness of that questions or test item. So, if I have 100 students in my class and all students have given correct answer for test item 1, then facilitation value is equal to 1. Okay. Now, if for question number 2, none of the students give the correct answer, then facilitation value is 0. So, interpretation of that is, if all 100 students give correct answer, that questions is very easy, facilitation value is 1. If none of the students give correct answer, the questions is very difficult. No, that analogy is not true. Question is irrelevant. That is why none of the students has given the answer. Or the test, by that test item, what you want to test, that CO which you have written, and you want to test that CO by test item number 2, that CO may not be achievable. That is why nobody has given that correct answer. So, facilitation value 0 does not mean the question is difficult. Facilitation value 0 means the test item which you provided for the particular CO may not be achievable, or the teaching learning process you follow is not scattered to achieve that test item 2. So, that is why the facilitation value is 0. So, the highest value of the facilitation FB is 1, lowest value is 0. Now, how do we calculate this facilitation value in general? So, suppose in 100 students, if 80% students give correct answer, 80 students give correct answer, should I consider the facilitation value is 0.8? Now, if you see, if I take why it is not considered 0.8, what is the problem in here? Problem is, since the distribution of the marks or distribution of the students' marks follow a Gaussian nature, then if I consider all students to find out the facilitation value and discriminating index, the result may not be perfectly represent the facilitation value. So, that is why what we say, instead of taking entire students, we want to find out 2 groups, a group of good students and a group of less performing students. So, a group of good performing students and a group of less performing students. How do you do it? Suppose if I plot in x axis the marks. So, this side let us it is 100, then 90, then 80, then 70, and like that way marks. And this y axis, if I say number of students, number of students. So, in y axis if I take number of students and x axis if I take marks obtained by the students, total marks obtained by the students, and then if I plot this frequency curve. So, what is meaning? The number of students who got the marks between 100 and 90, I will put one number, then I put another number, then I put another number. If I plot this, this will follow a Gaussian distribution. Okay? Then, as we remember, if you know, everybody knows in a Gaussian distribution, if I take the 3 dB down, half power frequency, 3 dB down, electronics also half power frequency or half power frequency called in resonant circuits. So, if I take the 3 dB down, that means 70% of the population, then what is that? That means this portion can I consider as a upper group and this portion can I consider as a lower group. So, this is called RU, this is called R. So, this is called upper group U and this is called lower group L. So, upper group and lower group. So, how many students are there in upper group? So, this is 70%. So, 30% of the students are in upper group and 30% of the students in lower group. So, if I have 100 students, if I rank them 1 to 100, so first 30 students are upper group, last 30 students are in lower group. Okay or not? Understand? So, first 30 students in upper group, last 30 students in lower group. So, if I say marks obtained by all upper group students. So, suppose my test item 1 is carry 5 marks. Test item 1 carry 5 marks. So, upper group size 30, lower group size 30. So, if all students in the upper group get correct marks, full marks, and all students in the lower group get full marks, then only the FB is equal to 1. So, marks obtained by upper group. What is the marks obtained by upper group? Marks obtained by upper group is 30 into 5, full marks. Marks obtained by lower group 30 into 5, full marks. What is the total marks in upper group and lower group together? So, total group size is 30 plus 30. If all students get 5, then 5. So, that is equal to 1. So, if I want to derive the formula, do not see the slides, let us derive the formula. So, what it is come? Marks obtained by upper group plus marks obtained by lower group divided by the total group marks. So, if all 30 students is upper group given full marks, all 30 students of the lower group given full marks, then FB value is 1. That means question is very easy. Now, if all 30 students in upper group got 0 marks, all 30 students in lower group got 0 marks. So, 30 into 0 plus 30 into 0 divided by 30 plus 30 into 5 equal to 0. So, then FB is equal to 0. So, facilitation value is 0 if all upper group students get 0 marks and all lower group students get 0 marks, then facilitation value is equal to 0. So, the formula is FB is equal to marks obtained by upper group, let us marks obtained by upper group RU plus marks obtained by lower group RL divided by total group size 2 into n if the group size is n into test item marks. If the marks is 1, then into 1. If the test item marks is 5, then into 5. If test item mark is 10, then 10. Is clear? So, facilitation value will be calculated marks obtained by lower group plus marks obtained by upper group divided by the total group size into test item marks. Okay. So, let us an example. I will come to multiple choice question later on. First is summative exam. So, let us that here I have a 10 questions. I have a 10 students in my class. So, total number of students in class is 10. So, I want to calculate the facilitation value of test item 1. So, I have to calculate the facilitation value of test item 1. What is the highest marks? 10. So, first thing is that I have to calculate the upper group. So, I have ranked them 1, 2, 3, 4, 5. So, I have ranked the students and according to the rank I name them. Then I have to find out the upper group and lower group. So, what is the upper group size? From rank 1 to 30%. So, 30% of the 10 students, 30% of 10 students is equal to 3 students. So, the upper group is these students, these students, these students. So, these consist the upper group students. So, then what is the lower group students? So, from the last 3 students 1, 2, 3. So, these students consist of lower group students. So, this is upper group, this is lower group. Okay, I have done. Now, what is the facilitation value? Marks obtained by upper group. So, what is RU is equal to 10 plus 9 plus 10 equal to 29. Marks obtained by lower group RL equal to 8 plus 8 plus 8, 24. So, what is the value of FB? FB is equal to marks obtained by upper group RU 29, marks obtained by lower group RL 24. What is the total group size? 2 into 3, 6 students, and what is the highest marks of the question? 10. So, equal to 53 by 60. If you say that all 3 students get 10, then 30 into plus 30, all lower group students get 10, 30 divided by 60 is equal to 1. So, it is very easy to calculate the facilitation value. After you taking the test, evaluate the transcript, check one question by one question. Let us question number 1. So, first based on the total marks, you rank the students 1, 2, 3, 4, 5, 6 up to, there is a possibility that same two students get the same marks, does not matter, put them 1, 2, no problem. So, if a student got, suppose here a student got 45, next students got also 45, I can make them 3, 4, no problem. So, I arrange them depending on the total marks and then I find out the lower group and upper group, then I use marks obtained by upper group, marks obtained by lower group divided by the total group size. Okay? So, that is facilitation value. Now, suppose the question is multiple choice questions. So, test item 1 is a multiple choice question, correct answer is C. Number of students is 15. So, 30% of 15 students is equal to 4.5. So, let us 6 students, 5 students, sorry, 5 students. Okay. So, 1, 2, 3, 4, 5. This is consist of upper group. 1, 2, 3, 4, 5 consist of lower group. So, if test item 1 carry 1 marks, then marks obtained by upper group RU is equal to, so how many have correct? 1, 2, 3, 4. So, 4 person has given correct marks into 1, each question carry 1 marks, plus marks obtained by the lower group. How many given the correct answer? 1, 2, 3. 3 into 1 divided by, what is the group size? 5 plus 5. So, 2 into 5 into 1. So, it is 4 plus 3 by 10, 7 by 10, 0.7. If I calculate for item number 2, this is test item number 1, test item 1. If I calculate for test item 2, then how many upper group? 1, 2, 3, 4, 5. So, all 5 given correct answer, 5 into 1. Lower group marks 1, only 1 plus 1 into 1 divided by 2 into 5. So, 2 into 5 into 1. So, it is nothing but a 6 by 10, 0.6. So, any test item for any evaluation, I can calculate the facilitation value and discriminative. I come facilitation value, discriminative index I come later on. So, suppose this again I come to this table. Can you calculate the facilitation value of test item 2? So, marks obtained by upper group 10 plus 10 plus 9, 29. Marks obtained by the lower group 8 plus 8 plus 7. So, 16 plus 7, okay, 23. So, 29 marks obtained by upper group plus marks obtained by upper group 23 divided by all students give correct answer 3 into 10 plus 3 into 10 or 3 plus 3 into 10, 52 by 60. Okay. So, you can practice for test item 3, 4, 5. Similarly, here also test item 2, 3, 4, 5. Find out first facilitation value. Okay. Done. Now, I go for discriminative index. So, what is discriminative index? Means how difficult is the questions. What do you mean by discrimination? Discrimination means how good is the question to separate the good students over the bad students. So, that is why name called discriminative index. It will differentiate between good students and bad students. So, discriminative index, how do we calculate the discriminative index? So, what is said? It is differentiate between good and bad. So, what I consider? Discriminative index will be when 1, discriminative index is called DI. When it will be 1? So, it will be good when it discriminates the good students over the bad students. So, it will be 1 when only the upper group which are considered to be good students are able to answer the questions and none of the lower group will be able to answer the questions. So, DI will be 1 when only upper group can able to answer the questions, no lower group will able to answer the questions. So, when a calculation of the DI value, So, I only consider upper group marks, that means the lower group students I am not considering. So, that means marks obtained by upper group minus marks obtained by lower group. Then since I am not considering the lower group, so let us n number of student in upper group plus 0 number of student in lower group into the marks of the question paper, total marks of the questions. Let question is for 5 marks, then into 5. Have you understand? So, marks obtained by upper group minus marks obtained by lower group divided by n into the marks of the questions. Here I am not taking n plus n, because I am saying discriminating index means only upper group can give the answer. So, again if it are 100 students in my class and only upper group 30, lower group 30. So, only upper group students give the correct answer. Let that each question is carry 5 marks. So, what is the upper group marks? 30 into 5, all upper group get 5 out of 5. No lower group get any marks, 0 divided by 30 into 5 equal to 1. So, di is equal to 1. Then when di will be 0, if I see that facilitation value 1, that means the marks obtained by upper group and marks obtained by lower group is same, full marks. All upper group and all lower group get the full marks. So, di will be 0 when the facilitation FB is equal to 1. There may be a possibility FB is not 1, but di may be 0. Possibility is there, because suppose here I am saying the 4 students of upper group, or out of 30 students, let 20 students of upper group get 5 out of 5 and 10 students get 0. In the lower group also 20 students get 5 out of 5, 10 students get 0. Then 20 into 5 minus 20 into 5 equal to 0. But when FB is equal to 1, di is definitely 0. FB is equal to 1 means 30 into 5 minus 30 into 5 divided by 30 into 5 is equal to 0. So, when facilitation value is 1, then discriminative index is 0. That means, if the question is easy, then di that is not able to discriminate the good students and bad students. So, what is the meaning of di equal to 1? Di equal to 1 means only good students can give able to answer. Only good student can able to answer. What is the meaning of di equal to 0? That means facilitation value is 1. That means all students can give that answer. But can di will be negative? Possible. Suppose you design a questions, no upper group students able to give the answer, but some lower group student is able to given the answer. What is the meaning? Meaning is that question is so ambiguous that by chance the lower group student has given that answer, and that is by luck he can get that marks. So, when you get di is equal to negative, that means test item is much more, it is possible that the test item is ambiguous. Okay? Now, let us I give an example, same example in here I can use it. So, let us erase it first and then so let us this table. I want to calculate the di value for this table. So, I have a 10 students, I have calculated the facilitation value for test item 1. Now, I want to calculate the DI value for test item 1. So, what is DI value of test item 1? Marks obtained by upper group 29, marks obtained by lower group 24. So, 29 minus 24 divided by what is the group size of upper group? 3. What is the highest total marks of the test item? 10. So, it is 5 by 30. Okay. So, I can calculate any value for test item 2. Marks obtained by upper group 29, marks obtained by lower group 8 plus 8 16 plus 7 23 minus 23 divided by 30, 6 by 30. Similarly, for multiple choice questions, for test item 1, marks test item 1, every test item carries less 1 marks. So, marks obtained by upper group 4 into 1 minus marks obtained by the lower group 3 into 1 divided by 5 into 1. So, that means 1 by 5. So, after taking the test, after providing the marks to the students, analyze each and every questions, find out their facilitation value and discriminative index. Then you can say, if this type of question I design, this is easy or difficult for this type of student setup. So, the facilitation value calculated for a college A or institute A, department A may not be applicable to institute B, department B if it is not statistically significant. But if the population is statistically significant and the college A and B input quality is almost same, then you can say that that will be applicable here. Means if I collect all the institute of India, that suppose a course for thermodynamics and all kinds of test item whatever has given by the many institute, I collect all data and I calculate the average average value of that facilitation value and discriminative index, that may be applicable to everywhere. But for your class, it is your duty to calculate, and when you design the question paper for the next year, then you know what kind of facilitation value and discriminative index I want to do. For summative examination, which is criteria based, we do not want to design a question paper which discriminative index is very high, because the question paper will be selected based on the CO, not based on the DI and FB value. But if somebody told you to grade your students, then how do you do that? There is another one also. You see the NBA said complex engineering problem. This complex is vary person to person, institute to institute, you can say the program to program. So, in a one class, suppose I am designing a test item for CO, let us CO1. So, I can give two test items, one is which is maintain the minimum requirement by which I can say, okay, these students has achieved the minimum requirement, but I can design another test item by which I can grade them. Even if in my class these students achieve minimum requirement and these students achieve high. So, for that purpose this test item analysis I can use. Have you understand what I am saying? For every CO I am not designing one questions, I am designing many questions, many test items. So, I can say so when I calculate the attainment of the CO, I may consider the question number 1. If a student achieve question number 1, they have attained the CO. but I can give question 2 and 3 related to the CO1, which I will want to measure what is the highest achievement level. That can also be possible. Okay. So, that is why this test item analysis has to be carried out. Okay. So, thank you.